Okay, here we go. This is a Unit 4 video tutorial for pages 6 and 7. What we're doing right now is mixed review. So the first thing you need to look at is labeling them I for ionic or C for covalent. Now remember our tricks. If it has a metal in it, it's ionic. If you see any prefixes, it's definitely covalent. So looking at number 5, I see di and hepta. So I know that this one has to be covalent, because covalent compounds will always have at least one prefix. Number 6, mercury 1 oxide. There are no prefixes, so it's probably ionic. There's a Roman numeral, so it's definitely ionic. And mercury is a metal, so yeah, it's ionic. Okay. For number 5, if we're using covalent, formulas are translating. Prefix in front to just the number in back. No crisscross, no reduce. So we're going to say dinitrogen means N2, and hepta is 7, not 6. Be careful that you're memorizing those prefixes correctly. So N2 heptachloride would be Cl7. Done. We like the covalent ones. Mercury 1 oxide is definitely ionic, so we're going to use our ionic formula rules. Symbols, charges, crisscross, reduce, and erase. I'll scoot this over, and I'm going to show my work over here for this, okay? The symbol for mercury, remember that's a gross one. It's Hg. Yeah. So Hg. Oxide is oxygen, so O. That's step 1, symbols. Step 2, charges. We wouldn't know mercury, but I told you in the name. Mercury making a 1 charge, oxide. And oxygen is a nonmetal. Nonmetals need negatives. No. Nonmetals need negatives. So oxygen would need 2 more negatives to be like family 8. It would need 1, 2 more to be like the royal family. So it would need 2 negatives like that. That's step 2. Step 3 is to crisscross. If mercury makes a 1 charge, then I need 1 oxygen for it. If oxygen makes a 2 charge, then I need 2 mercuries for it. I can't reduce 2 over 1, but I can erase the 1. Okay, this 1 will be invisible. So Hg2O. So there's more to it. For naming, okay, again, it's really important that we know if it's metals or nonmetals, because it will make a huge difference in the name. Number 12, sulfur and oxygen are both right here. So sulfur and oxygen, if I point to them with my fingers, I would make a C, YMCA. Okay, they're both on that side of the periodic table. So that's going to be covalent. So even though it's not required, I'm going to write covalent there, because I don't want to mix those rules up. Iron is over here. So I have something, oops, let me get on the screen. I have iron here and iodine here. So I know that that's something from each side. Let me try that again. From each side of the periodic table, over here and over here, it's going to be ionic if I have a metal. Alright, so now that I know which are which, I can look at naming. Covalent naming. Names must have at least 1 prefix. So S2, the 2 behind, becomes a di in front. So disulfur. Remember, I don't change the "ide" in the middle of the name. Disulfur. And then O7, 7 is hepta. So heptaoxide. Heptoxide. This one becomes ide. And then just like a little rule is that we drop the A in front of oxygen. So instead of heptaoxide, it's just heptoxide. So if your name starts with a vowel, like O, we usually drop the A. It's no big deal if you put heptaoxide, though. Disulfur, heptaoxide. For this one, naming rules, let's check our ionic rules. Naming. Alright, names may have Roman numerals. Be careful. We've got to be checking for that. Iron definitely needs 1. It's not in the exception block. So it's going to be iron blank. Blank. And then I is iodide. So we need to make our best guess about what these charges are making. I have 1 iron bonded onto 3 iodines. So my best guess is that the charges were -1 and a +3 if I uncrisscross. I can check if that guess was correct by looking at the nonmetal. Iodine does need 1 negative to be like the noble gases. So that charge is correct. So I can say correct, check mark, and then use this as my metal charge. Iron 3, iodide. Number 15, Pb2CO3. It's harder when it's multiple choice because you see lots of kind of sort of right answers, okay? First thing we need to look at, is it ionic or covalent? Lead is definitely a metal. Lead pipes, it's a metal. So I cannot use prefixes. I only use prefixes for covalent. So I'm going to go through and take out the garbage. Any prefix here is garbage because it's an ionic compound, no prefixes. And then I check, does lead need a Roman numeral? Lead's here. My exception block, if I outline it, is right here. So yes, lead has to have a Roman numeral, which means B is garbage. It doesn't have a Roman numeral. Okay. So is it lead making a 2 charge or lead making a 4 charge? Carbonate makes a 2 charge. Huh. You know what? Neither of those answers are right. The answer is lead 1. So why don't we just write that in? I didn't know that before. Lead 1. That's garbage and that's garbage. Carbonate. And then write haha, because you caught us making mistakes. Lead 1, carbonate. Down here, do I use Roman numerals? Do I use prefixes? We're looking. Phosphorus and carbon are both on that side of the periodic table. So this is covalent. Okay, because they're both here. Covalent names must have at least one prefix. So I can go through and take out as garbage anything without a prefix. Penta's got a prefix, mono and hexa's prefix. Phosphorus 3-chloride, no. There's no prefixes and we don't use Roman numerals for covalent. Phosphorus chloride, no, because there are no prefixes. Okay. So now we can check. Phosphorus pentachloride looks fine. Monophosphorus, I never start a name with mono. Mono only goes to the second element. So I know that one's garbage. Plus hexa is 6, not 5. There's my answer. Let's look at page 7. Page 7 is what we learned about in class today. It's molecular geometry, Vesper models, the 3D shapes that simple compounds tend to make. Okay, so we learned about 3 different types of compounds, 3 different shapes. Check your notes if you were absent, or if you weren't absent and you're not quite sure. So I'm looking at this. This is BF3, boron trifluoride. Okay. I see 1, 2, 3 bonds, and the prefix for 3 is tri. So this is going to be my shape that starts with tri, trigonal or trigonal. A trigonal planar molecule. Okay. So I'm going to look at this one. I can count the bonds and it looks like 3, but it's not making 3 different shapes or 3 different atoms. So really what I do is I check and I say I can cover this one up with my pen, and that one, and that one. Okay. So my pen is a straight line, this molecule is a straight line. I would call it linear. That's a linear molecule. And then looking over here, I have 1, 2, 3, 4 bonds. 4 is tetra. So this is a tetrahedral molecule. Okay. That was the new stuff we learned. Thanks so much, y'all.